Hello everyone, welcome back to another session by K21 Academy. Today our experts trainer will be talking about Azure Data Lakehouse overview and concepts. So let's get into the video.
So Lake is that democratic service in which we would be storing the data out of these sources. So these are the sources of the data that we identify. And where will we stage it in the cloud? Staging. We're going to carry out the staging of this data. We'll stage it in the cloud. And we quickly identify that that service ought to be data lake. It cannot be anything else. Reason? Apart from a lake, it's not going to accept. Only the lake accepts everything in the raw and the native format, allows you to keep it clean in the folder structure and a proper security using the access control list. So we quickly identify that that service ought to be an ADLS Gen 2. It has to be ADLS Gen 2. So this is our lake, Azure Data Lake Storage Generation 2, which will provide us two crucial features, HNS, hierarchical namespace, and operating ACLs, that is access control list. It's going to allow you to store each and every aspect of this. But the question that arises is, how do you bring it in the lake? What is the strategy to bring this in the lake? And there comes data integration. We have to integrate the data. Okay. Integration of the data is needed, movement of the data is needed, maybe some transformations are needed on this data before you stage it in a lake. So a technology for ingestion has to be arrived at. We have to think about ingestion, right? So ingestion, source, ingestion, and then staging. So depending on batch and real-time ingestion, let us say the data is batchy. So for batch, the most crucial choice as far as this course is concerned is what? ADF or Synapse pipelines. So to do data integration, centralized data integration, copy movement, transformations, which are called as mapping data flows, which you will learn very shortly in the module 6. Mapping data flows, mapping data flows. Maybe some orchestration is also needed. Orchestration is also needed, which is called as dispatches. We'll see what dispatches are. Dispatch. So to carry out all these things before staging, the choice should be Azure Data Factory, or equivalently Synapse pipeline. They are one and the same thing. They are not two different things. Some people always ask this question, are we covering ADF? Are we covering ADF? When you learn Synapse pipeline, you are learning ADF. They are not two different products, right? So to ingest, how would you do ingestion? We're going to look at these sources and design our pipelines and then bring it in the lake. So we bring it in the lake. Lake is an object storage, as you know, lake. So we're going to bring it to our lake. Here is our lake. We're going to design highly effective, highly efficient, highly robust data movement, data transformation, data orchestration pipelines. Choice would be data factory. Our choice to do that would be a data factory or Synapse pipeline. If you have some real-time sources, streaming sources, you can use IoT hubs, event grids, service bus, Kafka topics, and so on and so forth. That is also the choice. But because we are looking at data warehousing, we look at our batch sources, right? Because data warehousing is a batch process rather than a real-time process. So we bring the data to a lake. Now you think about what will we do in a lake? What to do after staging it in a lake? Now this is what we have to think about. It is called as a lake because it is not ready for consumption. It is not a packaged drinking water bottle, right? So it is a lake at this moment and it needs transformations. ETL to be done on the data of the lake now. Now the data of the lake will be massive. You can have petabyte scale living over here. You can have extremely large volumes of data sitting here. So we would need to extract the data from here and transform it and load it somewhere. And we are talking in the context of modern data warehousing. So what will we do? Right, you guessed it right. We're going to extract it from the lake, author data frames, create data frames on that data, transform those data frames and write them to the warehouse, structured warehouse, data warehousing. So to transform this data, what would be your choice? We need a parallel distributed processing framework that should be blazingly fast. Spark. We would need Spark. Spark is a parallel distributed big data processing paradigm or a framework that processes the data in the random access memory, as you know, right? And RAM is 10,000 times faster as compared to the hard disk drives, right? So we're going to be extracting the data out from here. Extract. And where will you process it? So the choice of processing is this, that prepare this data for downstream applications, transform them. If enrichments are required, enrich the data with more information. Enrichments, prepare, transform, and enrich. What would be the choice of that service be? You can have 4 different choices here as far as this course is concerned, right? Indeed, you can have 4 different choices for the data transformations, preparations, and your enrichment. What are they? Number 1, Azure Databricks clusters, right? Databricks clusters, Azure Databricks clusters, right? Second, Synapse Spark pools, Synapse Spark pools. Yes. Third, Azure HD Insight clusters. More specific, HD Insights Spark cluster. Spark cluster. And the fourth is open source Apache Spark. Do it yourself. Set up your cluster yourself. Open source Apache Spark. 4 options. But obviously I have written them in the order of priority. Highest priority, then the priority, then the priority, then the priority. Databricks clusters are the king of the jungle, right? All the advanced features in the Spark world you will find in the DBR, because the company Databricks itself does all the, because Databricks is a company who is founded by the original creators of Apache Spark, Matt Azaria and all those people. They founded a company Databricks which essentially invented Spark at the Berkeley labs, right? AMP labs at Berkeley. And the state of the art discoveries, inventions, Photon, right? Your project Lightspeed that is coming for streaming at this moment, Photon, Delta Lake Engine, Lightspeed, all the latest and the greatest inventions and essentially the optimizations are done by his company. Then it comes to the open source world when they make it open source out of their courtesy, right? And Synapse Spark pools are the implementation of Spark by Microsoft. So they have some differences in them. I would be sharing a table with you later down the road. Right now, I'm not going to share it because if you read it, you're going to get a little carried away with the technical terms, but I would be sharing it as when I feel it that, okay, now let's share it with our people. They will go through it. But obviously the king of the jungle is Databricks, followed by that Synapse. Then you have other options as well. So we're going to have to extract the data and use a parallel distributed processing paradigm, which is Spark, and all of them give you Spark for you. So we do this in this extract and then transform. Extract and transform. Now the question is, after you have done transformations, prepare, transform, enrich, where do you store it? Where do you take it? Right? Where are you going to take it? After extracting it from here, let me draw the diagram. Let me draw this arrow a little bit in a different way, otherwise it may confuse our people. So extract, transform, right? Extract, transform, and where do you load it? Where do we load it? Right? Where do we load it? What are your thoughts? So we're going to load it obviously in the modern data warehousing architecture, in the MDW architecture. Where do we load it? We load it in the SQL structured data warehouse. So you're going to load it into SQL structured data warehouse, which is what? Synapse Analytics dedicated SQL pool. So you load it in a SQL structured DWH. Indeed, yes. We're going to load it to the data warehouse, and that is Synapse Analytics. Synapse Analytics dedicated, yes, dedicated SQL pool. That's nothing but a warehouse. If someone says data warehouse, that is nothing but Synapse Analytics dedicated SQL pool. You load it in here, in the MDW. This is modern data warehousing, MDW, modern data warehousing. Because now, what is the difference? Difference is source. Here the source was structured only 20%, but now we look at all the sources, integrate the data, bring it to a lake, and then to the warehouse. Lake and the warehouse. Lake and the warehouse. Lake and warehouse. Lake and warehouse. Yes, modern data warehousing. How do you load it here in the warehouse? How do we load it into the data warehouse? So essentially, if you look at this, you have to take your process data frames that are living here, process data frames that we have in Spark. Those data frames have to be loaded into tables in the data warehouse. Correct? So whatever the process data frames that we have in Spark clusters, those data frames have to be written, write them into tables. That's what you want to do, isn't it? How do you do that? So you have two popular technologies for this, which is JDBC, PySpark JDBC connector, which is very popular old method, serial method. This is serial write. But Microsoft has invented something for this product. For this product, they have invented something which is called as Synapse SQL connector. Synapse SQL connector. And what does this connector do? This connector does the reading and the writing both in the tables. We will see how. This I will share an exercise for you. You can try this one, just takes 15 minutes. You can try this exercise, very easy. And this is indeed in your course itself. You'll look at how do you use this Synapse SQL connector to essentially write these data frames to the tables, read the tables and write them to the data frame, to and fro, both sides, right? To and fro movement of the data, right? You're going to look at that. So in the modern data warehousing, our process data frames that we have in the Spark clusters will be written to the tables in the data warehouses using either JDBC PySpark serial and the Synapse SQL connector, which is parallel writer, parallel data movement service connector. And that's how we write the data to the warehouse. But is it always that you will directly write the data to the warehouse? Some companies also maintain process data frames in the Delta format on the Delta Lake for long-term storage of the data and subsequent Delta analytics. So rather than taking these data frames to the tables in the data warehouse, which is needed in case they want to do some reporting on that, okay? But another option is that you can, what? Second option is you can take these data frames, right? These one, right? Let me just join it here like this. Take these data frames and load them. Second option is load them to write them, whatever you want to say, to something which is called as process lake, which could be another lake account, but or a zone within an existing lake, but you're going to write it in a processed lake format, preference given to Delta, because it is processed data, so you may do some direct analytics on it. So better to maintain it in the processed lake. So we can maintain it in the processed lake, right? You can maintain it in the processed lake, which is another ADLS Gen 2 account, process lake, for long-term storage, preference given to .delta format. So how do you write those data frames? df.write, right? You have method df.write that you can use in order to write the frames to the lake. So this is the process lake writing, and this is this data warehousing. This architecture is the soul of most of the business intelligence products. I'm not talking about machine learning. Data engineers work in all forms and shapes in various teams. You might be in some ML recommendation system project. You might be in some chatbot development project. You might be in some IoT development. I'm talking about this course talks about our enterprise intelligence, business intelligence. So in that case, you can clearly observe what role a data engineer plays. And this entire architecture essentially is the soul of the entire operations of data warehouses. Various things technologically we will have to learn in this, and your course essentially revolves around this only. How do you design pipelines, transformations, dispatches? Okay, how do you design a lake properly? How do you use ACLs? How do you do transformations of the data using Databricks and Synapse, Spark pools, and then subsequently develop the data warehouses as the serving layer? So this is technically called a serve. And what do we do after this? What do we do after data warehouse development? That work is not our work, right? Our work ends here. Typically the job role ends here, but you know what happens nowadays in the company, right? They just want to hire a single individual who can do everything for them, right? They say that you need to know Kubernetes and you must have 20 years of experience on Kubernetes, right? So that's how it happens in the world, right? So typically the job role of a data engineer is still here. Post that is business intelligence developers. So our work is to develop a multi-dimensional model in the data warehouse. So till here is your job to develop the multi-dimensional model in the data warehouse. And then post that is semantic model development. So semantic model development will be done by business intelligence developers, typically semantic modeling, which means they will develop 2D and 3D cubes, 2D tables, 3D cubes, slice, roll up, roll down, right? Drill down, drill up, key performance indicators, business metrics, measures, KPIs, common data models. So that is typically done by SQL Server analysis services, SQL Server data projects, analysis package, right? In which you develop semantic model. So that technology for developing the semantic model happens to be your SQL Server analysis engine. So you're going to be using SQL Server SSAS, and Microsoft also has cloud version of it, which is called as Azure Analysis Services. Azure AS, not SQL Server, Azure AS. This is SQL Server, this is Azure AS. So they have it, which is essentially a RAM-based database that keeps your semantic model in the RAM, which you develop using Visual Studio SSDT and Analysis Services package. And once the semantic model is deployed on this, then you hook up your reporting tools. Your reporting tools are essentially, if you're a Microsoft geek, Power BI, maybe Tableau you're using, or you go hardcore, you might be using Python, let us say. So that is the world of BI development, which is also a very detailed thing, the DAX expression, MDX expressions. A lot of things are there in that world, but typically this is where you live. As a data engineer, we must master the art of pipelining, lake development, transformations on the lake using a parallel distributed processing paradigm like Spark, and proper understanding of the dimensional modeling of the data warehouses. Secure it, manage it, administer it, operate it. And that's what the bread and the butter is. So this is the modern data warehousing architecture. This is so critical that if you sit in some high grade interview, not a normal, let us say, some people only ask basic questions, right? If they discuss with you in a detail, could you differentiate between traditional and modern data warehousing? Why do you call it modern data warehousing? What is the word modern used here? What is so modern in it, right? Has it come from the Paris fashion show that it is modern, right? So what is modern about it? Basically, it takes care of big data, right? Not only SQL, but essentially everything. Hence, a lake comes into picture. So now, if you observe, what is the drawback of this architecture? See, if you scrutinize it, there could be multiple drawbacks, right? But the primary drawback that is quite visible in here is that there are two data services that I have to now manage, right? A lake and a warehouse. These are the two services that I would have to typically manage, operate, secure, and all those things. A lake and a warehouse. Nowadays, you know, debate is going on in the data community that we must design products, especially for business intelligence, which are lake houses. Combine the lakes and the houses, lakes and the warehouses. Services that are products, solutions that must allow us to manage lakes and the warehouses in a uniform fashion, and even may allow us to carry out house operations on a lake. Yes, which is Delta Lake Engine, which essentially provides ACID compliance, analogous to how data warehouses provide ACID compliance, because data warehouses are RDBMS products, right? They have your locking, blocking, concurrency control, and ACID compliances. But to bring ACID compliances on the lake, Delta Lake Engine was invented, right? Delta format, Delta Lake Engine. So because of two different data services to manage, operate, secure, glue them together, and so on and so forth, nowadays you see that there are products that are allowing us to unify all this. So right from here, ingestion, lake management, lake attachment, prepare, transform, enrichment, serving, and then storing it back to the lake. Uniform management of all this are provided by the modern Lakehouse platforms. Snowflake, Databricks, Synapse Analytics is a Lakehouse platform, because Synapse provides you all these things in a single product, a single solution, gluing it together for you everything. Lakehouses.
So guys, if you liked our video, then do give us a thumbs up. But if you really want to learn more about the particular topic we discussed, then we have something really special for you. We have our free class on Microsoft Azure Data Engineer certification, that is DP203, along with some question and answers, where we'll be discussing about why is everyone working on data, importance of some Azure services you should learn, and many more things. So for that, all you have to do is just log on to K21Academy.com/Azure DE02, and after that you'll be seeing a screen like this. Just click on book your free seat now. Select your event date whenever you're available. Reserve your spot by adding your name, your email address, and your phone number, and you'll be getting all the updates via mail. You'll be seeing this kind of window on extreme right, so you can save this link, add to your calendars, and I'll see you in the free class. Till then, keep hustling and take care.